Good morning, everyone. So today's lesson is all about graphing exponential functions. So you're definitely going to need your calculator for this. If you're using that app that I told you, graphing calculator, I think it's x84, that would be the best one to use just because it's going to help you graph quicker and more efficiently. Okay, so all about today is just really honestly plugging into the calculator and finding points so we can graph. Okay, so for example, for this first one here, I have it set up for you so you guys can see what we're doing. So in this first equation, we substituted -3 in for x in order to get our y value. So that's what we're going to be doing for all of the x values here. So for the second one, I'm going to have y equals 3 to the -2. And here, if you remember, we are just going to bring 3 to the, remember, we can't have negative exponents. So we're just going to bring it to the bottom. So now we're going to have 1 over 3 squared. Okay? And I know that 3 squared is 9, so my final answer is 1 over 9. So I'm going to put this in the y value, and for this top one, I'm going to put it there too. Okay? And from there, you can then make a point because you now have an x value, and you now have a y value. So for the first one, we have -3, 1 over 27. For the second one, we have -2, 1 over 9, okay? Then we're just going to do the same thing with the following. So y equals 3 to the -1, which we all know any exponent, any negative exponent goes to the bottom. So now we have 1 over 3 to the 1, and I know that 3 to 1 is just 3, so my answer here is 1 over 3. So my new point becomes -1, 1 over 3, okay? And then I'm just going to keep going. So now I have y equals 3 to the 0. And we know our exponent rules that when anything is to the 0, we just get 1. So in this case, y was 1. So my point is 0, 1. Then I can just keep going. Now they're going to get easier, right? So now we have y equals 3 to the 1, and I know that's just 3. So my point now becomes 1, 3. I'm then going to substitute the 2 in for the x, and I know that 3 squared is 9. So my point is 2, 9. And then the last one, we have y 3 cubed, which is just 27. So my point becomes 327. Okay? Now, from here, we're going to try our best to graph it. Now, I understand that 1 over 27 and 1 over 9 and 1 over 3 are going to be super hard to graph, right? So we're just going to try and do our best. It's not going to be perfect. I'm going to zoom in really close, okay? So the first point I'm going to graph is this first, -3 and 1 over 27. So it's going to be super, super close. Just going to try our best. It's not on 0, but it's really close to it. Then we're going to go to -2 and 1 over 9, which gets a little higher. And then -1 and 1/3, which is about a third of the way. And then I have 0, 1, 1, 3, 2, 9, and then 3 and 27. It's just going to be, let's just say it's somewhere up there, okay? Now, I'm going to go ahead and connect these lines. What is super important is to realize that this line, is going to get closer and closer and closer and closer and closer to 0, but it will never touch, okay? Now, I understand this is not going to be perfect, but just to get the point, okay? That line will never touch 0. It will get so close to it, but it will never touch, which means there is an asymptote at x equals 0 because the graph will never go to 0. Okay? So now looking here, our numbers, when I look at my y values, my numbers went from really tiny and are slowly getting bigger. So we're going to look at this first definition here. Okay, since the y values increase, as the x values are also increasing, so we started with -3 and went to a +3, and then we started with 1 over 27 and went to a +27. So both the y values increased and the x values. So when both of those y values increase, this is called exponential growth. Okay, because the graph is going up from left to right. Right? We read a graph from left to right just as we read a book. So whatever the graph is doing, in this case, the graph is going upwards, we have an exponential growth. Okay? From here, if the exponential function y equals 3 to the x, the y values can never equal or be less than what? So now we just talked about this. What can my y values never be? We can never have it touch what? Okay? And in this case, we know that it can never be 0, right? So we're going to go ahead and put a 0 on that line. So our y values can never be equal or less than 0 because it can't touch the 0, it can't touch the x-axis, and it can't cross it, right? So we never want those values to be 0. Okay? Looking at definition 2. Since the y value can never equal 0 in the function, what did I say before? There is a horizontal what at y equals 0? Big word, it's a weird word. It's a horizontal asymptote. Okay? Right? So, when a y value can never be 0, there is always a horizontal asymptote, so it's never going to touch the y-axis. Sorry. All right, so we're going to flip to the next page. So now we're going to look at a different type of exponential function, okay? So we're going to do the same thing here. Now you're going to need your calculator, okay, because this one's going to be a little bit tougher. So just like in the first one, we were just plugging in for x, we're going to do the same thing. So in this case, my original function is y equals 1/3 to the x. So every time we see an x, we're now just going to plug in our x values. So here I have y equals 1/3 to the -3, right? And this is going to become, so what I want you to do is just type in your calculator, okay? So you're going to type y equals parenthesis 1 divided by 3, a caret, and then a -3, okay? And your answer will be a positive 27. So your x value is -3, and your y value is 27. Then you're going to do the same thing, but now your x value will now be a -2. And in this case, you're going to get a positive 9. So same thing in your calculator, y equals, open the parenthesis, 1 divided by 3, close the parenthesis, caret, -2. Okay, so your point is -2, 9. Same thing with the next, 1/3 to the -1, and your value will be 3 once you've typed it into your calculator. So -1, 3. Then we have y equals 1/3 to the 0, and I know that anything to the exponent of 0 is just 1, so my point is 0, 1. Then I'm going to start with my positive number, so I have 1/3 to the 1, which just gives me 1/3. So my point now becomes 1/3. Then I have y equals 1/3 to the 2, so I'm just going to square both the top and the bottom. So 1 squared and 3 squared gives me 1/9. So my point is now 2, 1/9. And then I have y equals 1/3 cubed, which I know I can just cube the top and the bottom, which just gives me a 1/27. So this point is 3, 1/27. Okay? Now we're going to go ahead and graph these. So I have -3, 27, so it's going to be somewhere up there. A -2, 9, a -1, 3, a 0, 1. And now this is where they're going to get very, very tiny. Okay? We're just going to assume. So now we're going to start left to right. So I'm going to start drawing my graph left to right. Okay? Once again, this line will never cross or touch 0. It will just get very, very close to it. Okay? Obviously, you can see where that's going. Okay? Now, since the y values decrease as the x values increase, this is an example of what? So if I'm reading this graph from left to right, it goes down. So this is called exponential decay. Okay? Now looking here, is there an asymptote? Does the graph ever cross or touch the x-axis? Or does the graph ever cross or touch the y-axis? And in this case, you can see right here that it touches the y-axis. So we know that there is not an asymptote there. But like I said before, your graph is never going to touch that x-axis. So in this case, yes, there is an asymptote, and it's at x equals 0. It's never going to touch the x-axis. Okay? So looking here now, an exponential function is a function that is generally in the form of a times b with an exponent. Okay? So if b is greater than 1, then the function shows what we call exponential growth. Okay? Because the graph's going to increase. Now, if b is greater than 0, but less than 1, which we just know is a fraction, then that kind of function will show exponential decay. Okay? So that's an easy way to, when it's just asking questions. So let's look at identifying these following functions and seeing if they're a growth or decay function. So if I am looking here at A, okay, and my B is 1.2. So if I'm looking at my two rules above that, anything greater than 1 is going to be a growth. So I know that's a growth. Okay? Looking at B, I have 0.8. I know it's bigger than 0, but less than 1. So that's going to be a decay. Okay? Then I'm going to look at C. I have a fraction, right? It's a half, which I know is not bigger than 1. So that's also a decay. Then I have 7 over 3, which is a fraction, but we know that 3 can fit into 7 multiple times, twice, right? So if I were to say 7 divided by 3, I would get 2.3333, which is bigger than 1, so it's a growth. Okay? And then down here, I just want you to write if it's a growth or decay looking at the graph. So remember, we read from left to right. So in this case, we're reading this way. And our graph is going up, so this is called a growth. While if I'm reading this way, my graph is going down, so this is called a decay. Okay? All right, I'm going to flip to the next page. So you are going to do the same thing here, okay? I want you to go ahead and practice. So the next 2 pages are going to be all about practice, okay? So in this case, we're going to tell whether the functions are exponential growth or decay by just looking at them, right? So if anything's greater than 1, it's a growth, but if it's less than 1, it's a decay. So I'm looking at this fraction. I know that's less than 1, so this is a decay. Okay? Now, looking at 2, this is a growth. Okay? Now, this one is important, y equals 1, because it doesn't say greater than or equal to 1, and it doesn't say less than or equal to 1 when we're looking at our little rules from the page before. Okay? So what's important to realize is that when your A or B is 1 or 0, it's going to say neither, because it's going to be just a straight line, right? It'll always just be 1. Okay? So that's important to realize. So on 7 and 9, it's going to be neither, because it's always just going to be a straight line. It's neither growing nor decaying. Okay? So same thing with 8. Is that a growth or a decay? I know that 5 is bigger than 1, so it's a growth. And then looking at 10, I have a fraction, 2 over 3, which is less than 1, so this is called a decay. Okay? So now we're going to work one more. You're going to do one more with me, and then you're going to do 2 on your own. Okay? So looking at this first one, I'm going to set them up all for you. So we have y equals 2 to the negative 3. Y equals, Oop, nope, I was right. Y equals 2 to the negative 2. Y equals 2 to the negative 1. Y equals 2 to the 0. y equals 2 to the 1, y equals 2 to the 2, and y equals 2 to the 3. Okay? So now you can do your math out. You know that anytime you have a negative exponent, it just drops to the bottom. And 2 cubed is just 8. Okay? But it would be 1 over 8. Same thing. The next one becomes 1 all over 2 squared, which I know would just be 1 over 4. And then I have 1 over 2 to the 1, because anytime we have a negative exponent, we bring it to the bottom, and that negative drops out, and I get 1/2. Then I know anything to the 0 is 1. And then 2 to the 1 is 2, 2 squared is 4, and 2 cubed is 8. Okay, so I'm going to make my points. So I'm just taking the x and the y values and making them a point. I'm going to go down my list. And then we're going to plot. So I have -3, 1 over 8. So remember, you're just going to do your best. I'm just doing my best, okay? And then these ones, you can actually make them look better. Sorry. I plotted the point wrong and confused myself. 2, 4, 3, 8. Okay? And then you're going to connect your lines from left to right. Okay? Now, reading this graph from left to right, I see that my graph is going up. So at the bottom here, you're just going to put growth. Okay? So I want you to go ahead and do the same thing for these next 2 problems. Do them on your own. Okay? Looking immediately, if you have a fraction, you can tell whether that's an exponential growth or decay right away. Okay? Here, you have to remember, I told you, when it's 1 and 0, they're important to look at, because are they going to grow or decrease, or are they going to do neither? Okay? So go ahead and check those out. I can set them up for you, and then you guys can do the answers. Okay? I'm not going to go over them with you, because at this point, you should be able to do this on your own. Okay? But I will set them up for you so you have an idea. So remember, you're just changing the x value to whatever it says. The bottom one is going to be the easiest, okay? If you have any questions on these, let me know. I will post a picture later if you need it, okay? Please let me know. So you're just going to finish the y values, make the points, graph it, and then tell me if it's an exponential growth or decay. All right? See you guys later.